Have you ever wondered, how does your TV remote control the television? How does a mobile tower communicate without using wires? The answer is wireless communication, also known as unguided media. Unlike guided media, where signals travel through cables,
Unguided media sends signals through free space using electromagnetic waves. Today, we'll understand it using simple, real-life examples. Let's begin.
Attention everyone! Tomorrow is a holiday! Did you notice something? The teacher didn't walk to every student. She spoke only once. Yet everyone around her heard the message. Why?
because the sound spread in every direction. A radio transmitter broadcasts radio signals in all directions, allowing many receivers to receive the same information simultaneously.
One transmitter.
Thousands, millions, even billions of receivers can receive the same broadcast. That's exactly how radio stations work. Radio waves are widely used for FM radio, television broadcasting, emergency broadcast systems, because one transmission reaches everyone within its coverage area. Only one announcement, yet everyone receives it. Similarly, one radio station serves millions of listeners simultaneously. Radio waves can travel long distances and cover large geographical areas. That's why a single radio tower can serve an entire city. The announcement was meant for only one class, but everyone nearby heard it. Similarly, radio signals are open to anyone within range, making them less secure.
Now, let us examine the next concept. It is very important for your upcoming test to hear. Similarly, radio waves can experience interference meters operating nearby.
Unlike radio waves, this light is not spreading everywhere. It is traveling in one focused direction. Microwave signals travel in straight, narrow beams. Communication suddenly stopped. Why? Because the flashlight could no longer reach Arjun. Microwaves require a clear line of sight.
The moment the path becomes clear, communication resumes. That's why microwave towers are installed on tall buildings and hilltops.
Think of microwaves like a beam of light. But obstacles like this hill can block them. They need a clear line of sight to connect.
Microwaves are commonly used in mobile communication towers, satellite television relay systems, point-to-point wireless internet links. The example we just saw is called terrestrial microwave communication. Here, microwave signals travel directly from one tower to another. Just like Rahul and Arjun needed to see each other, both towers must also have a clear line of sight. If a building, hill, or any obstacle blocks the path, communication stops. Since the Earth is curved, one tower cannot communicate with another over very long distances. So, multiple microwave towers are placed along the route. Each tower receives the signal and forwards it to the next tower. This allows communication over hundreds of kilometers. Terrestrial microwave communication is commonly used for mobile network towers, television relay stations, point-to-point wireless internet connections, and communication between cities.
What if Rahul and Arjun are so far apart that no number of towers can connect them? In that case, we use satellite microwave communication. Instead of sending the signal directly, Rahul sends it to a satellite in space. The satellite acts like a relay station. It receives the signal, amplifies it, and sends it back to Earth. The satellite works like a messenger in the sky. It receives information from one Earth station and forwards it to another Earth station thousands of kilometers away.
Satellite microwave communication is widely used for satellite television, GPS navigation, weather forecasting, international telephone and video communication, and internet connectivity remote areas. Let's compare the two types of microwave communication. Requires line of sight, requires line microwave, uses satellites in space, uses a satellite as a relay. Terrestrial microwaves are suitable for communication between nearby cities. Example, mobile towers. Satellite microwaves are suitable for communication across countries and continents. Example, DTH TV and GPS. Since the beam travels only toward Arjun, other campers cannot receive it. Likewise, microwave communication is highly directional, reducing interference. With a clear line of sight, microwaves can communicate over long distances, making them ideal for connecting distant communication towers. Even a single obstacle can completely block microwave communication. Microwave antennas must be precisely aligned. Even a slight deviation can interrupt communication. Your TV remote sends invisible infrared light. As long as it points toward the television, communication works perfectly. The infrared signal was blocked. Unlike radio waves, infrared cannot pass through people or walls. It requires a clear path. Infrared works only when the transmitter is aimed directly at the receiver. That's why you naturally point your remote toward the television. Every time you press a button on your remote, an infrared transmitter sends a signal. This invisible light carries a specific code that the receiver on your TV picks up. But remember, it needs a clear line of sight.
Infrared is widely used in TV remotes, air conditioner remotes, projector controls, some short-range wireless devices.
Since infrared cannot pass through walls, devices in other rooms cannot interfere. This naturally provides better privacy. Infrared communication consumes very little energy, which is why remote batteries last for months, or even years. Infrared communication is effective only over short distances, typically within the same room. Even a person standing between the remote and the TV can block the infrared signal. Let's quickly recap. Radio waves spread in all directions and are perfect for broadcasting to many receivers. Micropoint beams carry targeted data, while remotes use short-range infrared.